Bismillahirrahmanirrahim. Hello everyone. So hopefully you all will be fine. So today we will cover MCQs from MCQs number 121 to 130. But before going to that, if still you did not subscribe my channel, then kindly subscribe my channel and also press the bell icon for getting proper notification about my upcoming new video. So let's start from first MCQs, which is MCQs number 121. The current delivered by the dynamo is 11.1 ampere, 15.5 ampere, 18.7 ampere, 28.9 ampere. So let's say first of all we need to draw the diagram. Okay, so let's draw the diagram. So let's say here we have generator. Okay, and in generator I have series resistance that is 0.4. And this generator is generating voltage of 100 volt. Okay, so this is the shunt generator, yeah, shunt dynamo, and in shunt dynamo we have a resistance of 0.4 ohm. So that is, this is the resistance which is connected in series with this shunt dynamo, and also there is a battery, accumulator battery, which is connected in parallel with this shunt generator. So this is my battery, and there is also a resistance of 0.5 ohm. So this is the resistance of battery, and the no load voltage, yeah, terminal voltage of battery under no load condition is given to me, and that is 110 volt. Okay, so here the current is 40 ampere. So this is the output current. Output current is given to me, and that is 40 ampere. So let's say this current is IB and this current is IA. So one equation is like your IA plus IB is equal to 40 ampere. And let's say here we have terminal voltage that is V. So if you apply the loop analysis, so this is a plus, this is minus, this is the plus, this is minus, plus, this is minus. So here we have, this is rise, so voltage across battery is 110 volt. Then there is a drop, so that's equal to 0.5 IB plus V volt. V is the terminal voltage. Okay, so another equation is this, like we also apply loop analysis like this. So here this will be positive, negative, minus, plus. So here we get the another equation, and that is the 100 will be equal to 0.4 IA plus V. Okay, so here we get the voltage value, that will be 110 minus 0.5 IB is equal to V. Putting this voltage value in this equation, so you will get 100 is equal to 0.4 IA plus V, and V is 110 minus 0.5 IB. So this will come over here, and this 100 will go over there. So you will get minus 0.5, so this will be plus 0.5 IB, and this will be plus, so this will be minus 0.4 IA equal to 110 minus 100. So that will be equal to 0.5 IB minus 0.4 IA is equal to 10. So this is the another equation. and one equation is this. Okay, so from here I get the value of I get the value of IA. So your IA will be equal to 40 minus IB. Now putting second equation in this one star equation, so that will be equal to zero point 0.5 IB minus zero point 0.4. Instead of IA, I will write this 40 minus IB. That's equal to 10. So this will be zero point 0.5 IB minus 0.4 times 40 is equal to 16, minus time minus is plus 0.4 IB is equal to 10. So 16 will come over here, so it will become plus, so 16 plus 10 is 26, that's equal to 0 0.4 plus 0. So this will be 0.9 IB. So your IB will be equal to 26 divided by 0.9, so that is equal to 28.8. So your IB is 28.8. Your IA will be equal to 40 minus IB. IB is 28.8, and that is equal to, we will use calculator for this, and that 28.8. 40 minus 28.8. So that's equal to 11.2. So 11.2. This is my IA. So the correct option is option A, 11.9 ampere. Okay, next MCQ is the magnetic field which initially induces armature current in a self-excited generator is caused by permanent magnet, residual magnetism, and external DC source rotation of the armature. So the correct option is option B, residual magnetism. So what is mean by residual magnetism? So let's say we have a solenoid, and let's say the supply voltage is V. So if there is voltage V, then the energy stored in this conductor in the magnetic field, and if voltage is equal to zero, then that magnetism is known as residual magnetism. Residual magnetism. Okay, next MCQ is the condition for a shunt generator could be no residual magnetism, wrong field connections, field resistance more than critical resistance, permanent magnet demagnetized. So the reason for a self-excited shunt generator not building up the voltage could be, so no residual magnetism, then there will be no building up of voltage. If there is no residual magnetism, then there will be no building up of the voltage. If there is a wrong connection of the field winding, then also there will be no residual, no building up of the voltage. Also, if the field connection is wrong, then the building up of the voltage will be impossible. Also, field resistance, if the field resistance is more than the critical resistance, then it will be impossible to build up the voltage in the generator. And this will not be possible because permanent magnet is not unable to demagnetize. Okay. So the correct option will be 1, 2, and 3. 1, 2, 1, 3, 1, 2, 3, 2, 3, 4. So 1, 2, 3. So option C is the correct answer. Okay, next MCQ is Equalizer connections are required when paralleling to bipolar generator, shunt generator, series generator, compound. So the correct option is the compound generator. Actually, what is mean by equalizer connection? So it is simple a copper wire having zero resistance. And why we use equalizer connection? Actually, when you connect two compound generator in parallel, let's say this is G1 and let's say the second generation generator is G2, and let's say this is the bus bar, this is the positive bus bar, this is the negative bus bar. So this is my inductor of G2. Okay, so if let's say generator G1 voltage of G1 is equal to voltage of G2, then your I1 current will be equal to I2. But if your voltage of G1 is not equal to the voltage of G2, then what will happen? And let's say generator G1, voltage of generator G1 is greater than the voltage of generator G2, or you can say that the excitation of G1 is greater than the excitation of G2, due to which EMF produced by G1 will be greater than the EMF produced by G2. So then what will happen? This current excitation will increase. This excitation 1 will increase gradually and excitation 2 will decrease gradually. And if it increases gradually, then a stage reached where P1 excitation will increase too much and P2 excitation of G2 will be equal to 0. Then if the excitation of G2 will be equal to 0, then it means that EMF produced by G2 will be equal to 0. Then what will happen? This generator G1 will supply current I as well as supply current to G2 generator. So now G2 generator acts as a load for G1. So what we do, we use a copper wire having zero resistance and short circuit these 2 points. So what will happen? So as here we have I1 plus I2 is equal to I. So if the voltage of G1 is not equal to voltage across G2, then what will happen? This generator G1 will generate a high current, and that extra high current will also excite the field winding of G2. So the excitation of G2 will increase, due to which its EMF will also increase. And in this way, we get a situation where your EMF produced by generator 1 will become equal to the EMF produced by generator G2. So when EMF produced by G1 is exactly equal to the EMF produced by G2, then the current in this equalizer connection will be equal to 0. So I1 will be equal to I2, and so you get the output load current. So this is a sort of equalizer connection. Okay, next MCQ is, in order to ascertain whether a generator is lag or wave worn on the basis of visual observation of the armature, one should observe the connections to the field winding, connections to the commutator, connections to the brushes, the direction of the end connection. So let's explain it a little bit more. So actually, we have winding, and winding of any machine have two types. One type is the wave winding and second type is the lap winding. So wave winding is simple. That will be like this as it move in the form of waves. Okay, and another type of winding is the lap winding. So in lap winding, there is a successive overlapping of coils. So how there is a successive overlapping of coils. So let's say this is my commutator and this is my segment 1, this is segment 2, this is segment 3. This will be like this. Then the starting of second coil will overlap on the first coil like this. This will be your knot and these two will be your sound. And this is the simplex lap winding because lap winding is further divided into simplex and duplex lap winding. Okay, so this is your simplex lap winding. Let's also draw the duplex lap winding. So your duplex lap winding will be like this. Let's say this is your commutator segments. So it will overlap two times like this. So this will be your duplex lap winding. So these four poles will be your north pole and these four poles will be your south pole. So if the space between the starting terminal and the finishing terminal is farther apart, then that is your wave winding. So here the starting and finishing space is further apart. But here that is but here the end of the armature coils is connected to an adjacent segment on the commutator. And also we use heavier gauge wire for lap winding as compared to the wave winding. So the correct option is the direction of the end connection. Option D is the correct answer. So through visual observation of the armature, then you can observe the direction of the end connection. If that is farther apart, then that is your wave winding. If that is not farther apart, that is connected to an adjacent segments on the commutator, then that is your lap winding. Okay, next MCQ is When the shunt field of a compound generator is connected across both the series field and the armature, such a connection is known as cumulative compounding, differential compounding, long shunt, short shunt. So the correct option is option C, that is the long shunt. So let's draw the diagram of long shunt. So this generator is generating voltage, that is Eg. Resistance of armature is Ra. This is your series field. This is your shunt field resistance. Voltage will be V. So this is your long shunt compound generator. Okay, next MCQs is a self-excited shunt generator failed to excite because the residual magnetism has destroyed. In order to revive the machine, one should connect the armature to an AC source, connect the field to an AC source, excite the field for a few minutes with a battery, excite the armature for a few minutes with a battery. So the correct option is excite the field for a few minutes with a battery. So I discussed in detail about the residual magnetism. Okay, next MCQs is two generators having series excitation are connected in parallel. If equalizer bar is not used, one of the generator may stop, one of the generator may get reversed. Both generators may start hunting. Generator with lower shunt resistance will share more load. So the correct option is option B. One of the generator may get reversed. So let's explain it a little bit more. Actually, series generator, normally we don't use series generator for the supply of electric power. So where we use series generator, we use the parallel combination of series generator in train for the purpose of electric braking, and we also use the parallel combination of series generator in booster. So if you don't know what is mean by booster, so you can ask me in the comment box. I will try to answer you there. Okay, so let's draw the parallel combination of series generator. So let's say this is your positive bus bar, this is your negative bus bar, and let's say this is your generator G1, this is your generator G2, and let's say this is the winding of generator G1, this is the winding of generator G2. Okay, so let's say generator G1 excitation is high. So let's say generator G1 excitation is high. So it means that my current I1 is high. So when current I1 is high, due to which I2 will get low, and due to which excitation of generator 2 will get low. Because as we know that my current I dot current I is equal to I1 plus I2. So if I1 is high, then I2 will be low. If I2 is high, then I1 will be low. Also, G2 excitation will decrease, and as excitation is decreased, So it means that its induced EMF will also get decreased. Gradually, I1 will increase more, I2 will decrease further. At the end, I2 will become reverse, due to which generator G2 also acts as a load for G1. And this happens when there is no equalizer connection. So let's draw the equalizer connection. Equalizer connection is just a copper bar having zero resistance. So we shorten generator G1 and generator G2 at this point. So as there is an equalizer ring, so what will happen from this equalizer ring? As you can see, equalizer ring shorting G1 with generator G2, due to which generator G1 also starts supplying current to the field winding of generator G2 through this equalizer ring, due to which field of G2 gets strengthened and due to which its induced EMF gets increased. So through equalizer ring, both generators stabilize rapidly. Okay, next MCQ is, if two compound interpole DC generators are worked in parallel, the equalizing bar must be connected in series field only, interpole field only, function of series and interpole field, none of these. So the correct option is option C, field of function of series and interpole field. So compound interpole DC generator is like this. And we use the interpole just to reduce the effect of armature reaction. And it is connected in series with the armature winding. Okay, like if this is my generator G1, this is my generator G2. So here this is my armature, this is my series field winding, this is my bus bar, this is series field winding. Okay, so this is your G2, this is bus bar. So we use equalizer function over here. So that is the function of series field and interpole field. Okay, same current flow in series and interpole, and here also same current flow in series and interpole also. Okay, next MCQ is, the external load characteristic of a D generator at rated speed is assumed to be linear and is as shown in figure 20. The load circuit comprises only resistance when the load's current is 50 ampere. The value of the load circuit resistance will be 0.9 ohm, 1.0 ohm, 1.9 ohm, 2.0 ohm. So as you see that this is a straight line, So resistance will be same at all points on this straight line. Okay, so here we have voltage that is 100 volt, but current is 0 ampere. So we need to find the voltage, find the resistance at 50 ampere. But here we need voltage and that is not given to us. So only one point, and that is this point. Here we have voltage and here we have current. So let's find the resistance at this point, and as we know that the Ohm law say that your R will be equal to ratio of voltage and current. So voltage is 90 volt and current is 100 volt, 100 ampere. So that will be equal to 0.9 ohm. So is there any value that's equal to 0.9 ohm? Yes, option A is 0.9 ohm. So this is the option A is the correct answer. So this is the end of this video. Thanks for watching. Allah Hafiz.